All right, whenever you're ready, we're good.
Okay. Give it a go. Hi, folks. Welcome to this presentation at the Michigan State University Science Festival. My name is Tom Kuntzleman, and I teach chemistry at Spring Arbor University in Michigan. We're just about 45 minutes south of everybody in East Lansing. And this afternoon, I'm going to do some experiments with the element copper. And copper on the periodic table, you know, this is representative of all of the elements, all of the atoms that make up pretty much everything. And you can find copper on the periodic table. It's element number 29. Its symbol is big C, little u. It's from its Latin name, cuprum. And copper is a very interesting material, and I hope to show you some of the interesting facets of copper today. And you might be familiar with copper. It's a metal. It kind of has an orange sheen. This is the metallic form of copper. But you know, copper metal can undergo reactions to make it transform into a compound. And when copper undergoes reactions to form a compound, it becomes an ion. That just means it's charged. It's no longer just a neutral atom. It has a charge. And sometimes copper forms a +1 charged ion. Like in this compound here, it's copper oxide. It's like it's a little red in color, isn't it? Maybe a little bit orange. And that's what we normally see when copper forms a +1 compound. It gets like an orange or a reddish color. But copper can also form a +2 ion. And when it does that, it forms beautiful blue colors. And I want you to remember this today when we're doing our experiments that, you know, copper 2, that's what we call it. When it has a +2 charge, we call it copper 2. Copper 2 is blue. And copper 1, that's what we call copper when it has a +1 charge in a compound. Copper 1 is like red or orange. And then this is copper metal, which behaves like a metal. And these don't. These don't behave like metals, these compounds. So before I get into all of the experiments with copper, I want to do an experiment that sort of tests to see whether we have copper in a compound or not. And to do that, what I'm going to do is I'm going to do something called a flame test. This is a common test that chemists do to see if a particular element that we find on the periodic table is present in a compound. And what you do is you take that compound and you basically light it on fire because it's a flame test. And so what I'm going to do here is take this particular sponge. It's been soaked in some alcohol, and it's also been soaked in a salt. So there's been a salt that's been dissolved in the alcohol as well. And I'm going to light this flame, and we're going to see what we see. Let's see. Wow, that looks kind of pinkish, doesn't it? A little bit red. And when I see a red color in this particular flame test like this, it could mean it's one of two compounds or one of two elements. It could be the element lithium, which tends to burn with a red flame, or it could be the element strontium, which also burns with like an orange-yellow flame. But that's not copper. That's the one we're going to study today. So let's try this same test with copper. So here I have the same test. In this case, I've got some alcohol and I've soaked it in a solution that contains copper compounds. We'll light this one on fire. See what we get. Well, I'll bring a second lighter. Good thing I did. All right, let's try it here. Oh, look at that. That is gorgeous. You know, I think that this is a nice color for the Michigan State University Science Festival, don't you? Yeah, copper is sort of like a perfect element to study for the Michigan State Science Festival. Look at that green color, and it's on a white sponge to boot. Go green, go white, they say. Isn't that right? Beautiful. And it's probably no surprise to you that they use different elements, different salts of different elements, or different compounds that contain different elements to get the different colors that you see in fireworks. So sure enough, when you see a green firework, that firework probably has some of the element copper in it. So, the next time you're at the fireworks and you see a beautiful green display lighting up the sky, I don't want you anymore to go, ooh. Instead, I want you to say, oh, copper. All right. So let's remember that. Let's remember that copper, when it gains energy, it gives off like a greenish color. All right. More experiments. I think you're familiar with these. Some pennies. And you're probably aware that pennies have copper in them. We can see that nice orange color from the copper metal. And I have here some older pennies and some newer pennies. And we're gonna heat these and see if there's a difference between these old pennies here and the new pennies here. I'm going to use a blowtorch to do this. So let me get my gloves on, get my blowtorch going. I'm going to use this glass flask here. All right. Blowtorch going here. We're going to heat these pennies and see what we see. All right. Let's do a new one first. Let's try the new one first. Give me a little second here. It's a little tough to grab these with these gloves. Like that. There we go. Okay. All right. So this is a new penny. What's that date on there? 2017. So this penny was made in 2017. I'm going to go ahead and heat that penny. What do you see? What's going on there? Oh, I see something happening. Look at that. It looks like it sure is. It melted. That thing melted. And something came out. And the thing that came out, that doesn't look like copper. It's just been wet, so it's cool. So I'm going to go ahead and place it in my hand here. Yeah, that doesn't look like copper over here, does it? You can sort of see where the drip was. Let's see if I can pull this one out. What is this? Huh. That looks silvery to me. That's silvery, all right. New pennies minted after the year 1982, they're not actually made of copper. Well, there's a little bit of copper. They coat them with copper, but most part of the penny is made of the element zinc. And zinc has a silvery color, and zinc melts pretty easily. It melts at 419 degrees Celsius, which can be accessed that temperature can be accessed using this blowtorch. And so the new pennies, well, they're made of zinc, and then they coat them with copper because, people are used to pennies being made of copper. But that's why they coat them with copper. Let's try the same experiment with one of these old pennies, shall we? Let's see what happens. All right, get a blowtorch going again. Check out our old penny. Old pennies made before 1982. This on there, and here we go. What's going on? Is it going to melt? Something's happening. Is it melting though? I don't think it's melting. Oh, it's starting to glow. Look at that. It's like getting orange hot. It sure is. It's glowing orange. It's so hot. I've got this thing so hot and yet it won't melt. Well, that actually makes sense to me because old pennies were made of copper. There's a little bit of zinc in there too, but it's mostly copper. Look, I'm still heating that thing's not melting. And that's because the melting point of copper is 1,083 Celsius. It is way up there. It's very difficult to melt copper, even with this blowtorch. Now, I want you to watch this carefully. I'm going to pull this out of the flame, and let's see what happens to the color of the penny. Move it away. See what happens. Doesn't look like a penny anymore. Well, okay, it looks like a penny, but it doesn't look like the color of a penny anymore. It looks black, doesn't it? It sure does. And you know what that tells me? That tells me that the copper on the penny is reacting with oxygen in the air to make copper oxide. So we've now taken the copper metal and we've made it a compound out of it. We've made a compound. I'm going to go ahead and put this in the water and let's see what happens. Hey, look. I see flakes coming off. It looks like the copper oxide is flaking off. And I can see the bare surface of the copper metal again. Not so much on that side. Maybe that side cooled a little more. I don't know. I don't know what's going on there. But sure enough, a lot of the copper oxide flaked off of this side, so I can see the copper metal. And then, of course, here in the flash, you may be able to see the flecks. Maybe not. Sheet it here. You can see it there. Oh yeah, there we can see them. Now we can see the flecks. See the flecks of the black copper oxide. Yeah. So there's some differences between new pennies and well, old pennies. Quite a bit of difference, actually. We expect that, of course. I'm going to try this one more time because sometimes when I do this experiment with these zinc pennies, the new pennies, sometimes when I do it, I see brass form. Well, what's brass? Brass, I can see a little bit here, but I'm going to try to do it where it works a little better. Brass happens to be a mixture of copper and zinc. So to speak, when the copper and the zinc melt together, they make brass, which is like golden color. Brass is a golden color alloy. It's a mixture of copper and zinc. And I don't see it real well on this one. I'm going to try again. Let's see if we can't get some some brass to form, which again is a mixture of copper and zinc melted together. It's actually what we call an alloy of those two metals. Try it one more time. Let's see if I can. Let's see if I can get some brass to form on the penny as we get the copper and the zinc to melt together. Let's hope for the best. Sometimes I see it, sometimes I don't. Oh yeah, I sure got it that time. I can totally see it. Make sure it's wet. Try to. I don't know if you can see it at home. We're getting a little bit too much shininess on the. Let's see. Let's try a blue background. See if that works. Try to see if you can see the. Oh, there you can see the golden sheen. Sure, you can see the golden sheen on the penny, and that happened as the as the zinc melted out of the penny. It mixed with some of the copper plate on the surface, and we sure enough formed some brass, that golden colored alloy of copper and zinc. I'm glad I got to show that for you. Sometimes it doesn't work. I'm glad it worked this afternoon. Okay, let's do another experiment. I'm gonna get a solution. I'm gonna bring out a solution. Let me get the solution here. Here's the solution. What color is that solution? Of course, it's blue. And if it's blue, and if there's a copper compound that's been dissolved in there, which type of copper ion do you think is in the compound that I dissolved? Do you remember? I mentioned it earlier that when copper ions are in the +2 form, they're blue. And so I took a salt that's similar to this one that contains copper ions, and I dissolved it in some water to make the solution. You know what we're going to try and do? We're going to try to get the copper to come out of this solution as a metal. That's right. We're going to try to do it as a metal. Well, how are we going to do that? Well, to do that, I'm going to add a metal to the solution that's more reactive than copper. Aluminum is a very, very reactive metal, very reactive. And so I'm just going to add some aluminum for this, and we'll see what happens. We'll see if we can't get the aluminum metal to react with the copper ion. I'll put up a couple of these. Get 3 going. A little more fun to do 3, I think. All right. And then we'll put in some aluminum foil, and we'll see what happens. Here we go. In goes the first one. In goes the second one. Oh man, look at that. What's going on there? Hey, wait a minute. I wonder if there's like little particles of copper being emitted. Let's find out. Oh, you see that? What color was that flame? You notice the color of that flame? Gotta watch carefully. I don't know about you, but I'm seeing a green flame. Beautiful. Let's put this one in here. Let's get 3 of them going just for fun. Man, I see a lot of stuff going on in here. I see some bubbles. Woo, I'm seeing some green flames. Man. We'll talk about this in a bit. Let's just play for a little while. Oh, that one seems to be running out, yeah? Beautiful green flame. Sure enough. That green flame tells me there's probably some copper in this mixture, right? Remember that at the beginning when we did the flame tests? I'm kind of doing a flame test here. We're testing that vapor for the presence of small amounts of copper ion. We might be running out here. Well, that's really going. Okay, let's see what else we have here. Well, it's getting hot. You can't see that at home. Boy, is that hot. Yeah, really hot. I also see some solid stuff. Do you see that solid stuff? What color is that solid stuff? A lot of people say, hey, that look, I've done this experiment for people lots of times. And a lot of people, when they see this experiment, will say, hey, that's rust forming there. And when people say that, I like to remind them that rust has iron in it. Iron position on the periodic tables right here. Well, I didn't put any iron in these cylinders. There's no iron in there. I did put some copper in there, though, right? From the dissolved copper salt. You put some of that in there. So if you look closely, you actually might notice that the color of that stuff that looks like rust, you know what? It kind of looks like the color of a penny. Kind of looks like the color of a penny. Maybe an old penny. It's a little bit reddish, isn't it? A little bit orangish. But yeah, it's the color of a penny. And so what's happening here is that the copper metal that's dissolved in the solution, that's blue, it's actually reacting with the aluminum. The aluminum's getting dissolved, and the copper that's in solution, it's actually plating out, we say. It's plating out as copper metal. And so these little tiny pieces of solid that you see forming, those are pieces of solid copper metal coming out. Now the bubbles that you see, there's another reaction that happens to go on with this. It's the formation of hydrogen gas, and hydrogen gas reacts with oxygen in the atmosphere to form water, and it releases a lot of energy. See if we still got some here. Oh, I don't think that one's gonna work. And there's that one. Oh, that one's not either. I think we're out. Yeah, unfortunately, I'm not making enough hydrogen gas quick enough to get that reaction to go, but those tiny explosions that you saw, those were the reaction between the hydrogen gas being evolved, oxygen in the atmosphere, forming water and releasing a lot of energy. And the green that you saw, that's just an indication that there's little tiny particles of copper being emitted as well, probably copper ion, just little tiny little pieces of it. I love that experiment. That's a really interesting one. Okay. At this point in our presentation, we're going to go on a field trip. We're going to go to the hood. When we say the hood in a chemistry class, we don't mean the neighborhood. What we mean is there's like a box that we put in the lab, and that box is there so that if poisonous or problematic fumes are emitted in an experiment, then when we carry out that experiment in the hood pumps the air out and away from the experimenter so that it can go into the atmosphere, and so that I wouldn't be inhaling the potentially problematic fumes that we're going to see in the experiments that follow. So we're going to head on into the lab, to do some experiments in the hood. And on the way, maybe we can take a stop and look at our, put this on the, yep. We might check out our Lego periodic table on the way. Let's do that. Might as well show folks that. This is our Lego periodic table. We built this, I think it was in 2011. We built this periodic table, as you can see, entirely out of Lego blocks. And, well, here's our element we're studying today, right? Here's copper. Oh, I got a little piece of Lego there that's colored copper. It's a copper colored brick. And oh, it looks like I put a penny up here. And here's the Statue of Liberty. We have the Statue of Liberty there because the Statue of Liberty is made of copper. And it doesn't have this color because the outside coating of the Statue of Liberty has reacted with components in the atmosphere to form copper-2 compounds. And if you're interested in the Lego periodic table, you can, here, let's show them the site here. You can visit it. You can click on and learn more about all the different elements and play around a little bit. And there's some jokes on here. Let's see. Can you figure out why we put Batman on this? This is the element. This represents the element sodium. Sodium's Latin name is natrium, which is why its symbol is capital N, little a. Maybe you can figure out why Batman's on sodium's square. The old time Batman song. Na 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 Batman. That's the joke. All right, come on, we'll head on into the hood, into the lab, so we can do some experiments in the hood. Okay. I think the first experiment we'll do. I'm going to take some of these little pennies that I have here, and we're gonna put it in some acid. So what we're going to see in this case, these are old pennies. They're made of copper, and so what we're going to see is what happens if we take the copper metal and actually turn it into a compound. The acid is going to react with this chemically, and it's going to change it from the metal form into something else. And we want to see what's going to go on there. If you hear a little humming in the background, the humming is the hood at work. So the humming is the pump pumping the air through here and out into the atmosphere and away from the experiment. So go ahead and take this beaker here, and let's put our penny in. Turn it this way, yeah. And then I'm going to add some concentrated nitric acid to our penny. We're going to watch what happens. There goes. Man, I see lots of stuff. I see some green. I see some bubbling. This. Sorry. Move it this direction. There we go. Yep. If need be, we'll slide the screen down a little bit. Man, I see some orange gas coming off. I see bubbles. I see some green stuff. Well, there's a lot going on there. I imagine what's happening, you know, if we think about what we've learned so far today, that the nitric acid is reacting with the copper and the penny, and it's changing it from a metal to a compound. And I kind of guessed that because I see a little bit of green color there, a little green-blue color. You can see the gas coming off too. Good thing we got the hood at work. Yeah, when you're doing chemistry, anytime you see a colored gas, that's not something you want to be inhaling. So that's why we're doing this particular experiment in the hood. So that gas is actually nitrogen dioxide. Nitrogen dioxide is, well, that's the component of something that we often see when automobiles, a lot of automobiles are running in the same city. You may have heard of smog before. Component of smog is nitrogen dioxide. And so sometimes when there's a lot of smog, you see sort of a brown color in the air. And that makes sense, you know, nitrogen dioxide, look at that, it's a brown gas. Unfortunately, fortunately, automobiles don't all emit that much nitrogen dioxide and be in trouble. But they do emit enough that sometimes we can see that color in the atmosphere. All right, I want to try this experiment in a little different way. What I'm going to do here, we're going to do the same experiment. All this one's running. But this time, I'm going to try to collect the gas that comes out, and we're going to get it in this water that's here. And I want to treat this water a little bit specially first. What I'm going to do is I'm going to add a little bit of base. Base is a type of a chemical that reacts with acids. Acids and bases react and they neutralize each other. So it's going to put in a few drops of this base. I'm not sure this is going to work, by the way. Okay, I was trying to get it to work this morning. It wasn't working, so we'll see. So I've added my base, and now what I'm doing is I'm going to add an acid-base indicator. What this does is it tells me if this water is acidic or basic. Well, I just added a base to it, so we know it's going to be basic. And this particular indicator, it's going to be colored blue if it's in a base, and it's going to be colorless if it's in an acid. I'm going to add some of the acid-base indicator. Oh, I see some blue color developing. Do you? Sure. That's because I added some base to this. I'm sure I added enough. Yep. I'm going to add a bit more. Well, I'm not sure I'm going to do that. I don't want to put too much in. But sure enough, we know I added a base to this because we saw that I did it. And plus, we've added the acid-base indicator, and this is turned blue. All right, remember, it's colorless in an acid. I will place this in here. We're going to repeat this experiment. But this time, we're going to put the pennies in this flask, and I'm going to seal it. And then the gas that'll evolve, it should go through this tube, and it should bubble into our water that contains the acid-base indicator. Here we go. I'm going to add these first. Get this going. Add the lid. Let's roll here. Get that stoppered off. See what happens. Oh, look, it's bubbling over there. Sure is. We know the gas bubbles are going through. Same thing going. That's kind of cool. If I can hear it tickling around in here. You can even see the brown gas here in the tube. I see a little bit coming out here. See a little, oh, What do you notice? Look at that color. What's going on there? What happened to the blue color? It's gone. The blue color disappeared. What do you think is going on there? Well, remember, I told you that this indicator that I added, it's blue in a base, which I added, and it's colorless in an acid. So what happened with this particular gas, when it bubbled through this water here, it made the water acidic. And we can tell that because the color went from blue to colorless. Isn't that interesting? And this happens with a lot of gases. Carbon dioxide is another one. When certain gases dissolve into water, they form acids. And nitrogen dioxide happens to be another one of those gases that when it dissolves in water, it forms an acid. And so there's certain things that we do with burning of different fuels that do release certain compounds into the air, like nitrogen dioxide and also carbon dioxide, that we have to be careful about and we have to monitor to make sure that when we release these gases into the atmosphere, that we're not doing things that are harming our environment or harming our way of life. And there's a lot of scientists at work studying that, trying to make sure that the activities that we do here on planet Earth aren't impacting us in negative ways. Let's do one more experiment. One more to go. I'm going to place this over in the other hood. We'll keep this focused on this reaction here. Pop this over here. Now, right. One more reaction I want to do. Here it is. Excuse me. And we can take some questions. What in the world is this? Oh, I got my test tube here. I can put this up for this one. All right. Get this out of here as well. The next reaction. Okay. Let's look at this particular test tube real closely. What do you see? Well, I see, let's pay attention to the color. I see some blue-green colored stuff in my test tube. Do you? Yep, I do. And that blue-green colored stuff, that tells me that, well, there's copper-2 in there. It's a compound that actually has copper-2 ions in it. This particular compound happens to be called copper-2 formate. I'm going to try to shake it around here a little bit to get it coated all over the inside. And what I'm going to do is I'm going to heat this. I'm going to heat the copper formate. We're going to see what happens. All right. Let's try to stir that up just a little bit better. Okay. Pop it back in there and get it flatter. We'll heat this. We can see what happens. Hope for the best. All right, we set? Here we go. Well, looks like I got a little darker in color. I got a little darker here. Let's keep going, see what happens. Oh, look at that. You see right there. I don't know about you, but that looks kind of shiny. Looks like a shiny orange. Looks like a shiny orange metal. I think. Look at that. Oh, that's so beautiful. I think by heating this compound that has copper-2 in it, I was able to, well, I wasn't, the chemistry of this thing did, I was able to form some copper metal. You can see that nice shiny mirror there. Here, let's heat this side. This side. Look at the side that I did not heat. It's still kind of blue. Let's heat this side so you can't get this to go copper metal. Oh, that's so pretty. Yep, all the way up the test tube. That's really neat. So by heating copper formate, we were able to change the copper 2 ion back to some beautiful, shiny copper metal right there in the test tube. So let's head on back into the regular room. We can finish up. If folks have any questions, head on in. Let me grab this. All right. Slide it in. See if we got any questions in the chat. Hold on a second. We're getting squared away here.
I don't think we have any questions yet. If people want to put them in the chat or on Facebook, I will watch them. To get us started, I don't know if I know this, but what got you interested in chemistry?
What got me interested in chemistry to begin with? You know, I had a course in college. It was a chemistry course. It was just general chemistry, and I had a teacher, professor. His name was Dr. Schultz, and he did experiments in class. And it was the first time I had ever seen chemistry experiments done live. And when I saw that, it blew my mind, the kind of things that he was able to do with a variety of chemical compounds. And I was absolutely hooked. I was like, you know what, that's what I want to do. And I really enjoy doing that. I truly enjoy just doing chemistry experiments and seeing what happens and trying to explain them using what people have figured out over, hundreds of years about the world.
Yeah, that's awesome. So someone asked a really fun question. If we torch the Statue of Liberty, will it shine?
That's a great, you know what? Let's try it. We can kind of try it. Let me show you why. Earlier today, I did some experiments on pennies to show why the Statue of Liberty is green. And that happens because the copper on the Statue of Liberty, it reacts with components in the atmosphere to form green colored compounds, the copper 2 ion. And so what I have here is one of those pennies. Yep, there it is. One of those pennies that I made this morning. So, it's not going to be exact. The chemistry is not going to be exactly the same, but there's a green coating here, very similar. I'm sure the chemistry is similar to the coating that you'd find on the Statue of Liberty. And so the question was, if you heated the Statue of Liberty, would it turn it back to the metal? Well, let's kind of test that idea by heating this patina with my blowtorch, if I can find it. Okay, there it is over there. I got to make sure I got all the stuff I need. Here we go. Yep, here we go. Got this. And we're going to heat this with a blowtorch. We're going to find out what happens. Let me get our control. This is the one. This is a patina over here that I'm not going to heat. And I'm going to just compare the two. Let's find out. Come on. Every once in a while, it gets a little tricky to get this thing lit. There it goes. All right, here we go. It's a great question. I'm so excited to find out what's going to happen. I've never done this before. Here we go. Here we go. Would you see that little flash of green? Going orange, kind of got black, didn't it? Well, I better be careful. Look at that green. Oh, that's gorgeous. That really tells me there's a bunch of copper there. I think it's, look at that. I don't know, folks. You may be able to argue that that's kind of gone back. Maybe that's going back to the metal. I don't know. You know, we'd have to do a careful analysis of that. I honestly don't know. It's potentially possible. I think this is a zinc penny. I think it's going to melt. Let's find out. Look at that green. Oh, I hope you can see that on the video. It is just all over the place. Yeah, look at that's going to melt. I don't know. I think the jury's out, but I think it's potential. I think it's got potential. Great question. Great idea. I wonder if I'll be doing that experiment quite a few times to see what's really going on. Other questions?
I don't see any more. Wait a couple seconds here. Do you have any other resources you'd like to highlight for people?
Yeah, they can, you know, I've got a YouTube channel that does goofy experiments like this that I put out every once in a while. It's Tommy Technetium. That second word is named after this element here, element number 43. It's Tommy Technetium. It's on YouTube. You can also check out my Twitter handle. It's PChemStud. And you can also check me out at Spring Arbor University. You can always contact me by way of email there.
Yeah.
And the person who's hosting today, Hazel Anderson, she was a student her freshman year at Spring Arbor University. She went on to bigger and better things. She went on to Michigan State University, but she was a student in my class, and we did some research together. We did some experiments. So that was great. And now Hazel's moving on to study to be a doctor at a doctor of science biology at Michigan State. So congratulations.
Thank you. Yeah. Lots of fun experiments in class, I remember.
Yes. Well, thanks.
All right. Well,
Good to see you, Hazel.
thank you, everyone. Thank you, Dr. K.
So long.
Bye.